Students, we are learning lesson number 7 from the paper first, and in this lesson number 7 we are studying about lenses. And in this lenses, before this we have studied which are the basic concept or terms related to the lenses. So which terms are there, what are the lenses, types of the lenses, what are subtypes of the lenses, that one we have studied. Now we'll repeat that one for a while, and then we are going to start next part. So in that you are knowing two types of lenses are there. Main two types are there. First one is there, convex lens is there, and another one is there, concave lens is there. Concave lens. So in that convex lens, so at the center it is thick and at the edges it is thin. In case of the concave lens, it is like this. At the center it is thin and at the edges it is thick. And some terms also we have studied. So we are knowing, suppose you will draw one imaginary circle here. That circle will have its center, suppose here will be C2. Again if you will draw another imaginary circle and its center will be there, C1. So these C1 and C2, these are the centers of curvature. So which terms we have studied? Terms related to the lenses, centers of curvatures. Centers of curvature. So each lens has two centers of curvature, C1 and C2. Second point we have studied, radius of curvature. Radius of curvature. So radius of curvature. So two spheres are there. So there are two radius of curvatures, R1 and R2. Suppose you will draw this one will be the R1. Suppose this one is the sphere S1 and this one is the sphere S2, and this one will be R2. So each lens has two radius of curvature or radii of curvature. Third one is the principal axis. So in that principal axis, it is the straight line joining two centers of curvatures. It is a straight line joining two centers of curvature, or straight line passing through two centers of curvature. You are saying this one is their principal axis. So principal axis, it is joining C1 and C2, two centers of curvature. Then after that, fourth term we have studied, that one is their optical center. So optical center, it is the point, midpoint of the lens, point inside the lens. Suppose we'll draw one lens here. Suppose it is a point inside the lens. Suppose this one will be principal axis. Then it is the point inside the lens. If light rays are passing through that point, particular point, they are going undeviated, without changing direction, they are going straight. That point you are saying optical center. Here will be optical center. It is the point inside the lens through which, if incident light rays are passing, they are going, or they are passing through the optical center, through that point, without changing the direction, its direction. So optical center you are denoting by O. Fifth point is there. So next point is there, principal focus. Fifth point is there, principal focus. So here it is also having two principal foci, F1 and F2. Suppose if light rays are coming, here we will draw a diagram. for understanding principal focus. Here will be optical center, suppose, and here will be principal axis, and suppose here will be C1 and here will be C2. If light rays are coming parallel to the principal axis from this side, suppose light rays are coming parallel to principal axis, but after refraction they are meeting at single point, they are passing through the single point on the principal axis. Suppose this one will be F2, principal focus. Suppose light rays are coming from another direction, opposite direction, and they are coming parallel to the principal axis, but they will after refraction they will meet at single point on the principal axis, and that one will be the F1. So if light rays are coming from that direction, then also they are meeting at single point on the principal axis, and that point you are saying focus. So principal focus, there are two principal focus, F1 and F2. So next 6th point is there, we have studied, that one is their focal length. So what is the focal length? And it is denoted by small letter F. So focal length, it is the distance between optical center and principal focus. It is, you are saying, focal length. You are saying it is the distance between optical center and principal focus. It is called as a focal length. So these terms we have studied. Again, definitions also we have studied there. That one you have to revise again, because these terms are most important for drawing the ray diagrams. And in case of the concave lens also, here will be one, C2 will be there. If you will draw here imaginary circle, here will be also C1, principal axis will be there, optical center will be there, here will be F1, here will be F2. But this distance, you have to remember one thing, that F1 or principal focus is midpoint of that particular radius of curvature. So like that you can consider. So here 2F1 and here 2F2, you can take double distance with that. That's why you can take like this way. And all terms are similar, only in case of our principal focus only little bit change is there. Suppose this one is there, lens, optical center is there, then suppose here F1 is there, suppose C1 is there, here F2 will be there, and here C2 will be there. But if light rays are coming parallel to the principal axis, after refraction they are diverging lens is there, so they get separated, they are diverging. So it is it looks like they are coming from a point behind, or you will you will extend the dotted lines, that it looks like refracted light rays are coming from a point on the principal axis, and that point you are seeing principal focus, and this one will be the focal length. So these points you have to remember. Convex lens is their converging lens, and concave lens is their diverging lens. These things you have to remember. After this next point we are going to study, and that one is there, try this. And in that try this, some questions are there, and their answers we are going to get. We are going to find their answers, and after that we are going to study about rules to draw the ray diagrams. So one by one we'll see. So try this one activity is given, and that simple activity is there, it is given in the textbook. Same activity we will perform during the practicals. So we have to find the focal length of that particular lens, whatever it will be, convex lens. So one thing you have to do, try this in this one table you will take. On that you will draw one straight line. Here you will fix, here on one side you will fix one screen, you will fix screen. Then middle you will keep one stand, and that stand will be the lens stand will be there. Here you will fix one lens, and here will be tree or something will be there. And if you have to adjust, two ways are there you can adjust. So one thing is that you can move the screen towards the lens. This one is the lens, this one is the screen, this one is the object, lens and screen. So light rays are coming from the object, they will come parallel but up. This one is the converging lens, so they will converge on the screen, and here image will be formed, image will be produced. And where you are getting clear image, there you have to stop. So and after that you have to measure the distance. This distance you have to measure, distance between a lens, and you have to measure the distance between screen, and that distance will be their focal length. It will be focal length of the convex lens, focal length of the convex lens. And same experiment you have to revise by changing the sides of the lenses. So this side was there, this side was facing towards the object, that side you have to take towards the screen. That means sides only will change, and after changing again you have to do the same activity. Again you have to find the focal length. So with the help of this one you can understand it, the distance between lens and the screen, that one you are saying focal length. And another one thing you have to remember, focal length F is equal to, it is the half of the radius of curvature, it is half of the radius of curvature. So focal length is equal to R by 2. This is the relation between focal length and radius of curvature for all the types of lenses. So after this we are going to study about some rules to draw the ray diagrams for the lenses. So diagrams, or what you can say, images formed by the lenses, for that some rules are there. That 3 rules we are going to study. So which are that rules we'll see. So 3 rules are there. That 3 rules we'll study one by one. So rules to draw ray diagrams. So what are the rules? That rules we are going to study. So there are 3 rules. There are 3 rules are there to draw the ray diagram. So in that first rule is there, rule first is there. First we'll draw the diagram and then we'll write the rule. Suppose you will take one straight line, it will be your principal axis. So one straight line you are going to draw. So one straight line you will draw on your notebook. After that, one thing you have to do, you have to take some distance in your compass box and compass, and then you have to make like this way arc. And suppose this distance will be, here will be your C1, and from another side also you have to take some distance and you have to make another arc like this way. You have to make another arc like this way, and you have to join these points. Then where that 2 points are meeting, these 2 points are meeting, there will be your optical center will be there. And from where you are making arc, that one is there, C2. Again one more thing is there. This one will be radius of curvature, so half distance here will be there, F2, and here also exact at midpoint there will be there, F1. like this way diagram will be there, and this distance OF1 and F1 to C1, this distance you are taking 2F1, here you will take 2F2, because these two distances are same, equal. So first rule is there, if incident light ray is coming parallel to the principal axis, if incident light ray is coming parallel to the principal axis, then refracted light ray passes through, refracted light ray passes through the principal focus. Incident light ray is coming parallel to the principal axis, then refracted light ray passes through the principal focus. This one is their incident ray, this one is their refracted ray, incident ray, refracted ray. So rule you have to write. What is the rule? If incident ray is parallel to principal axis, incident ray is parallel to the principal axis, then refracted ray passes through, principal focus, This is the rule. If incident light ray is parallel to the principal axis, then refracted light ray passes through the principal focus. Second rule is exactly opposite to this one. That is rule number second is the rule second. And in that rule, first we will draw the diagram. It is opposite to this one. So first what you have to do, one straight line, then take some distance and do one arc like this way. You have to make arc like this way, and here will be your C1. From here you are taking some distance and you are making another arc. Here will be your C2 will be there, and if you will join these 2 points where it will meet to principal axis, there will be your optical center will be there. Exact limit point here will be F1, exact limit point here will be F2. Now second rule is there, if incident light ray passes, suppose incident light ray is coming, incident light ray is passing through principal focus, then refracted light ray goes parallel to the principal axis. If incident light ray is passing through the principal focus, then refracted light ray goes parallel to the principal axis. So rule will write here. What is the rule? So if incident ray passes through, principal focus, then refracted ray goes parallel to principal axis. Refracted ray goes parallel to principal axis. So this one is the second rule. If incident ray passes through the principal focus, then refracted ray goes parallel to the principal axis. And third rule is also there, simple one. I will rub first one and then I will write third rule. So these are the rules to draw the ray diagram, and by using these rules only we have to draw the ray diagrams for convex lens as well as concave lens. So third rule is there. In that, first we will draw diagram. Principal axis you will take some distance in the compass and you will do one arc, and from where you are doing that, here will be C1. From that side you will also do one arc with the compass. Suppose here will be there C2, and if you will join these two ends, then it will cross to the principal axis, and that point will be their optical center, and exactly midpoint here will be f1, exactly midpoint here will be f2. But according to third rule, if incident light ray passes through, if the incident ray passes through, or it is passing through optical center, then it does not change the direction. Refracted ray does not change the direction. Refracted ray goes straight. So rule is there: if incident ray passes through optical center, if incident ray passes through optical center, then refracted ray, or also you can say emergent ray, refracted ray does not change its direction, it goes undeviated. You are saying undeviated, it is not changing the direction, it is going straight. If incident light ray is passing through the optical center, then refracted light ray goes straight, it does not change the direction. So these are the three rules, and that three rules we have to use for drawing the ray diagrams, and these three rules you have to remember. These are same for the concave lens also, concave lens. So after this we are going to study next point, and that next point will be there images formed by the convex lenses, or convex lens. So for that the 6 positions are there. We'll take that positions one by one. Before that, one activity is there, try this. That activity also we are going to take. So you have to write these rules. So what is the try this activity? That one we are going to we'll write that one. We'll see what is that activity. So that activity you have to conduct with the help of screen, with the help of lens. Again, you have to conduct with the help of burning candle. So try this is there. We'll see what is given in the try this. So what you have to do, one table you take, on that you will draw straight line. After that you have to take one screen. Here it will be screen. Then after that, middle you have to take one lens stand you have to take, and on that you have to fix the lens stand will be there. Here will be lens screen, and here you have to take one burning candle. So you have to take one burning candle. So you are knowing what will happen. Lens is the convex lens, so that light rays will go parallel to the principal axis, and they will get converged at single point, and here image will be produced. Another one more thing you have to remember. Suppose lens you will take, here will be optical center, here will be C2, here will be C1, here will be F1, here will be F2, principal focus. And this distance and this distance is same, this distance and this distance is same. So you are writing here F1 and 2 F1, and here also you are writing F2 and 2 F2. So same thing you are going to I am going to show here. So what will happen now? Here will be infinity. Here will be infinity. Light rays which are coming from infinity, or object which is far away from that object, when light rays are coming, that are coming parallel to the principal axis. And this lens is there, convex lens, converging lens is there. So for this we are going to study, for the what you can say, if you will measure this distance will be your focal length. This distance will be their focal length. So next point we are going to study about images formed by the convex lens, and at sixth position we are going to study. Initially we are keeping at infinity, after that we are keeping beyond the 2f1, after that we are keeping at 2f1, after that we are keeping between f1 and 2f1, after that we are keeping at f1, then where will be the image. After that last position we are going to study object will be there between f1 and O, where will be the image. So like this way we are going to study. So introductory 2-3 diagrams we will study today in this video. So one thing is that clear, this point we have to study images formed by convex lens. So there are 6 positions. Out of that, 2 positions will take here. First one is there object at infinity. If object will be there at infinity. So what you have to do, first thing is there, draw one straight line, take some distance in the compass and do one arc. Here will be your C1. To another side also take some distance in the compass and then make another arc and join these 2 points. Where they are meeting, there will be your optical center. Another, here will be there C2, but we are knowing focus is there exactly at the midpoint f1. Here also it will be there, here f2, and here you can take 2 f2. Double distance is there, so you are taking 2 f1. Here it will be 2 f1, f1 to f1, f2 to f2. So now we have to draw the ray diagram. So object will be there at infinity, and when object will be there at infinity, then light rays are coming parallel to the principal axis. And according to our first rule, if light rays are coming parallel to the principal axis, then they are converging. Where they are converging? They are meeting at single point at the focus on another side. So suppose first light ray parallel to the principal axis, after refraction it will pass through the principal focus. It will pass through the principal focus. So where they are meeting, there will be the image. Here object will be there at infinity. Object will be there at infinity, and image will be there. Image will be there. Image will be there at f2. So 3 points we have to write here. First one is there, when object will be there at infinity, then position of image. So where image will be formed? Image will be formed at principal focus. Suppose image will be there at f2. Principal focus f2. Second point is there. In that second point, what you have to do? So size and nature we are going to study. Size will be there. Size of image. What will be the size? Size will be there. Point image will be there, very very small. And third point is there, nature of image. Now here nature of image, in that 2 things are there, real and inverted. What will be the nature of the image? It will be real and inverted. Image will be real and inverted. Now what is mean by real image, what is mean by virtual image? So that one you have to understand. So real image, if an incident, suppose if refracted light rays are meeting at single point and image is formed, if refracted light rays are meeting at single point and then image is formed, that image you are saying real. And inverted, when you are saying, when it will be the below the principal axis, it will be upside down. So you are saying inverted. So another thing is there, second position we are going to take, object will be there beyond f1, sorry, 2f1, object beyond, beyond, beyond 2f1. Where you have to keep object now? Beyond 2f1, between infinity and 2f1. So first step you are knowing, you have to take some distance, then you have to make first arc. Here will be your C1. From that side you have to make second arc, then it will be C2, and if you will join these two, there will be optical center. Midpoint will be there f1, here midpoint will be there f2, and here you are taking 2f1, here you are taking 2f2. So now in the second case, where you are keeping object, where you are keeping object beyond 2f1, so object will be there here beyond 2f1. Suppose A, B is the object. So first light ray going parallel to the principal axis. We are knowing after refraction it goes through, or it passes through principal focus. Another thing is there, another light ray which is going, it is passing through the optical center. Another light ray passing through optical center. So it will not change the direction, it will go straight, and where that refracted light rays are meeting, there will be the image, and here will be A dash and here will be B dash. So upside down happen, that means B came to the downside. Here B is there above the principal axis, and here B dash is there below the principal axis. So image is there real and inverted. Real, when you are saying when refracted light rays are meeting at single point, image will be real. Inverted, when you are saying when it is formed below to the principal axis. So first point is there, position of image, where image will be produced. So image will be produced between, image will be there between f2 and 2f2, f2 and 2f2. B point is there, size of image. What is the size? Smaller than object. Smaller than object. And C point is there, nature of the image. Nature of image. So what is the nature? Real and inverted. So when you are saying real, when refracted light rays are meeting at single point and image is formed, then real, and inverted, it is formed upside down. So you have to draw these two ray diagrams. In next video we will see what is meant by real images, what is meant by virtual images, and as well as remaining four positions we are going to take. Object, now third one will be the object at 2f1, then fourth one will be there object between f1 and 2f1, fifth one will be there object at f1, sixth one will be there object between f1 and O. So remaining four positions we are going to study in the next video.